Good morning.
Good morning.
Thanks everyone to coming to the enterprise check. So I'm so glad that you come here at the first section of the day. My name is Colin.
I'm Kenny, Solution Architect from AWS China.
So I'm Colin. I'm the Vice President of Envision. So today I'm coming here to tell you the story about how we leverage IoT plus cloud to enable digital transformation for enterprises. Today we will go through a story, like talking about what kind of challenges we are going to face for enterprises and how IoT actually will put value for the enterprise digital transformation. And we could get into some of the details about the use cases in China especially and globally.
In my section, I will introduce how Envision leverage AWS service to build a security model on AWS and share the tips when you want to deploy Citrix on AWS Beijing region and SAP migration use case. Okay,
we take it from here. So for the first part, so we talk about new business model first, and then we talk about like IT, the traditional IT and migration to the cloud. Thanks Kenny. So I will start from the first part. Just a little bit about myself. So I was the Senior Director of Microsoft, the first generation working on Microsoft Cloud, which is Azure. After that, so I joined Alibaba. I was the CTO of the retail platform of Alibaba, the e-commerce platform. So the platform actually is the largest one, e-commerce platform. I every year, handle 3 trillion RMB, like the Chinese yuan, like volume of transactions. So which actually support like the highest peak load is more than 300,000 per second. I joined Envision 2 years ago. Since then, I started to work on the IoT platform, which enable Envision itself and our customer to do the digital transformation. That's the introduction about Envision itself. So Envision itself is an enterprise. So we are the number 8 wind turbine provider globally. So think about that. So we have in the past 10 years, we already produced thousands of wind turbine sets in China and in other countries. So think about that as a hardware provider. As some of you may have the same problem. How do you manage your products after you ship it? Like how to do like O&M and make sure that in the warranty, so you are going to continue to support your product. The second business Envision gets into is we become an asset owner. So we use our own turbine sets to to generate power and sell the electricity into the grid. So in this case, so again, right, as an enterprise, you may have lots of assets already in your enterprise. So how do you manage the performance? How do you how do you make sure that your operation cost is low and you create a really high ROI? It's a common problem for enterprise. The third problem for digital transformation of the enterprise is that, so we, as most of the companies, we are looking forward to new opportunities. So we're using technology to create the turbine sets, manage the turbine sets, and operate the turbine sets globally. And that is driven by our software. So actually we're using software to manage our asset, but we are thinking, is that like the same technology will be available to enable like other business? For example, do we using the same technology to manage the solar farms? Can I use the technology to manage transmission and distribution of the grid? Can I using the same technology to manage your home, your building and industrial parks? So that's where we can see that as an enterprise, we are thinking using digital transformation to create new business value and create new business stream. So in short, so we are facing 3 problems as a company, as an enterprise. First, we are a provider of the hardware. The second, we are asset owner. The third one, so we are looking forward to new business models and create new revenue stream for the company. So from today, actually, I want you to remember that for digital transformation, we need to use IoT. Why? So in the past, we have done a lot of digital transformation for enterprises. So what we have been doing in the past 10 or 20 years is that, so we digitalize our business processes between human being and the processes. For example, we're using SAP we are SAP Salesforce to digitalize our relationship with the customers, our relationship with the sales, our relationship with our employee for HR. So, but the next wave, that has been done for many, many years. Lots of companies have been successful to doing this kind of digital transformation. But the next wave has to be digitalize our relationship with the devices, our asset in the company. That's why we need to use another type of digital transformation using IoT plus the cloud. Think about that. Let me give you some context, in the energy sector. So because we're coming from the energy, from the utility, so we know about what kind of challenge we see. So do you know that every year, every hour, actually we are sitting here, there are 2.5 wind turbines are getting connected to the network. There are over 40,000 of the solar panels. They also connect to the new devices, connect to the network, connect to the grid. And we see it more and more, right? So you can see that from Tesla, from SpaceX, and from other companies, right? So we are getting new devices, smart devices getting into the network also, like the EV, electric vehicles, right? Like energy storage. So like the one we are running in the home, like the smart appliances. And all these actually are smart. They are driven by the connectivity, driven by the intelligence in the cloud. So all these devices actually are connecting to the cloud, which generate a lot of business values. From IDC report, we can see that even before 2014, think about that, there are 0.06% of the devices are connectable to the cloud. So even by 2014, right? So we can see, but by 2018, next year, the number of devices connected to the cloud will be more than the human population. And every year, the new IoT will generate over 10 trillion of new GDP in US. So as you can see that the next wave, really important is that, so besides the traditional digital transformation, we got to using IoT, the new technology, to make sure we connect connect to systems, and also connect to the devices. That's why we created the EOS on top of AWS. From here, the IoT platform, so what it does, it will connect all the devices in the power systems. So what a power system is, it is from power generation, for example, like the renewable power generation, like solar farms, wind farms, and also connecting to storage. But now, so in the past, we don't have any storage for electricity. What you can supply is what you can get eventually. But now, with the storage, the first time we can see that we could have inventory of electricity. So it makes sure that the electricity become a commodity. It become something you can trade, with dynamic pricing. So we also connect to the transmission and distribution network. After that, we connect to the demand side also. Demand side, which includes, for example, the smart building of this, or the industrial park, or your home, or your office. So now, once you're connecting all the devices into the cloud, what you can do? Actually, you could trade electricity based on a lot of factors. And then you could do, you also can correlate your maintenance, your operation maintenance with the market. So what we do is that we already connected to over 100 gigawatt of assets. What does it mean, 100 gigawatt? Think about if each of the light bulb in your home is around 20 watt. So that means it's a 50 billion of light bulbs connecting to the network. So in general, in terms of like how many sensors or devices we are connecting to, we connect to like 50 millions of devices so far. We have the project. So as an enabler of the enabler, we enable Envision XR to do the digital transformation. We also enable lots of utility companies to do the digital transformation. They are ranging from US to Europe and to China and to Asia also. And so here you can see that from here. So I talk about some of the projects we have gone through, and we will later talk about all the details. Now we are talking about on the technology part. So now we all know that like we need to use IoT, but IoT has a lot of implication about technical challenges. So first, let me give you some of examples of the technical challenges. Even back to like wind turbine business, right? So we are not only connecting to as an asset owner, you have like asset all over from different providers. Like wind turbines, you could get like from GE, you could get from Gamesa, you could get from like Envision, our company also. So now you have like lots of devices like in the field. How do you manage those devices remotely? They are talking about different protocols. They are talking about different data format. So they're using different controls. So they're using different sensors. That's the first hard problem is we have like so many diversified assets in the field. How do we make sure they could like easily to get into connect to the network? That's number one. The second one is like in terms of data. Think about data if for a human being, right? It's easy to understand that data is standard. Like if I hit a browser, and then I leave a trail of information, right? So column like in this time click a button, right? That's easily to be managed by the computer. But in terms of sensors in the field, first, so the connectivity can be intermittent. So because they are far away, not that many people actually can manage the devices locally. So the intermittent of data, we generate sometimes you get the data, sometimes you don't have the data. The second one is the outlier. The data quality is really bad. So from lots of time, the sensor information can jump. The data can jump like into a really high value and then drop to a really low value. But now what do you do, right? So what do you do with those data? Those are lots of garbage data. So how do you clean the data and make sure they could be useful for your machine learning or artificial intelligence later on? The third one is data. They're talking about data. Data have different format again, right? So we are talking about how to standardize those data. You are talking about, for example, solar panel or your home, your washing machine, right? So you have different brand of the data. So how do you like make sure the data could be unified and create a standard model for the application developers to manage your devices? That's a really hard problem too. Like, could make the standard? Could you like to map those data into a standard model? The last the question about data is really high frequency data. Unlike human being, right? You click, you talk, and then you have like the most, you have hundreds of entries per day. But now talking about machines. Machines can have a millisecond of the measurement. So for high frequency of measurement, like you could create like gigabyte of data per day, per machine, per sensor. So that's really like large amount of data. You get those data, how do you process those data? Like in a real time and in a batch time like fashion. So and they create value. That is the big data problem. The third one is now we are talking about intelligence. With data, with lots of data, we occupy lots of storage already. But if you cannot mine the value. You cannot do the data mining of your data. It's just garbage, right? So we can see that in more and more, we can see lots of customers store lots of garbage in their data center. But how do you create intelligence from there? Like, for example, intelligence must associate it with your business values. The first one could be like operation and maintenance. The second one could be enable trading. The third one could be like combine multiple scenarios all together. So those are intelligence. We need to think about that. Like we either using physical models, we either like using digital models. So we will talk about later about how intelligence can arise from lots of business values. After other connectivity, big data, intelligence, right? Those are the hot topics, right? Like all over the place already. But actually in the enterprise, we need to focus on the synergy also. For IoT, it's not just a vertical like information about your machine. In the enterprise, you've got to connect all the devices and make the data into a data lake associated with those data. You also need to create like operation synergy like of those data. Let me give you an example. Lots of people know about that EV is really important like these days, right? But do you know that like for fast charging of an EV, it requires over 40 kilowatt of power. But normally, lots of buildings or industrial parks have a capacity limit. So once you have like over 20, or last time when we in a campus like of one big enterprise, so they want to enable their employee to use an EV, but the maximum of the EV they can support like to charge at the same time is less than 20. But if you have like 1,000 employees, what can you do, right? So, but how about if you create a synergy about this, you correlate multiple systems together, you have multiple choices. First, you probably will get a storage like installed in your building. Like when everyone like charging their EVs, so we are not just using the power from the grid. We are also using a storage to buffer the charging. You also can reduce the load of your building. For example, you could lower the temperature of your building, or actually shut down some of the ACs, the air conditionings, or the elevators. The multiple choices you could juggle, right? You can like using multiple boards, you could handle to create a synergy between those systems. That's the value about IoT. It's not just like doing operation and maintenance. It's about synergy, about making all the parts working together. That's the information I really want everyone to understand. Like, so we are not just talking about vertical information. The last but not the least is security. Lots of people understand that, like from an enterprise, security is almost the most important topic. I really believe that some of the customers or even your enterprise, we talk about, oh, I have really important systems. That's my business. Everything is my business. How can I put it into the cloud? Right? It's dangerous and unsafe, at least in the mindset of your stakeholders. So that's why we need to think about that. How do you make sure that everyone understands the end-to-end security? It could be like I still keep my most important like hardware like outside of the cloud, but I need to bridge from the edge, like your on-premise like data center to the cloud. Right? I could like make sure that all the protection about data isolation, the authentication, and auditing about the data. So all this is really important topic about IoT. So we will talk more like on this topic. Like make sure that like we all understand the challenges in those 5 key pillars: connectivity, big data, how to create value with intelligence, how to make sure the data can talk to each other and create operation. Create a new operation, new business models. How do you like handle security, like from enterprise to the cloud? This is like what we like create. How we created a solution, IoT solution for the enterprises. So as you can see, that the middle big box is AWS. It provides all the scalability and performance and to our platform. Like under the AWS, actually we have an edge component. So we all, if you know about IoT, so probably everyone knows about what an edge is. An edge is a proxy. We need to have a proxy to bridge the protocols of all kinds of devices to the cloud. And we also need to do edge computing. For example, the edge can live in your own data center of your enterprise. So they will get the data. And so for example, in the grid, actually it's really, we call it security zone. The security zone need to be in the enterprise, but the information zone could be in the cloud. So the edge actually live in the zone 1, in the grid, in the power grid business. So they will pull the information and out from the local machines and publish those information to the cloud. And they can get the instruction or the controls from the cloud, and using another gateway to deliver the message to the local systems. local devices. But again, right, some of them cannot be directly controlled. They need to synchronize. They're not direct control. They're using a strategy. They need to create a strategy in the cloud and synchronize a strategy from the cloud to the local. In that case, right, you prevent the threat about be able to direct control your devices from the cloud, but you could create control your intelligence from the cloud and synchronize those intelligence to the local machine and ask the local machine to perform the actions on behalf of the cloud. On top of this, right, so now we have the edge, now we have the infrastructure, we have the storage. Now we need to, again, so for data, we need to create a common data models across multiple sectors. That's why in our platform, we created lots of data models, following the standard, for example, IEC standard for the transmission and distribution of the grid. So those are actually open for other people to plug in the industrial knowledge into our platform. After you have the standard model, so we need to have open platform for people to do data processing and also wide applications. That's why we need to create open SDK and tooling for application for application developer to keep publishing the application into our platform. So once we have lots of rich application set in the application store, right? So in your enterprise also. So your enterprise IT department or professional services department or your ISV could leverage those applications, bundle them together, and create a portfolio of business services for your business users. That's how we perceive that. So the key point here is we got to have edge computing. We got to have data models, common data model. We've got to have an open platform for application developer to keep helping your enterprise to building a rich set of applications. So we also need to have a data lake, right? And to make sure all the data will put together to enable the business value. So that's how our architecture actually enable for the digital transformation. Now take a look what we learned from the platform, when we developed the platform. What kind of technology actually we are using to be able to support those technical challenges. The first one is the connectivity. As we can see that so if you're using lots of open platform, you find out every time you need to connect to a device, you do a one-off job, right? So which we call business integration in our IT integration in the past. So but that's kind of ad hoc work, didn't bring you long-term value. Now in our platform, we develop a library, a device library. It's just like Windows, it's just like Android, it's just like Linux, right? We create those models, those device model, drivers for your device to be able to plug and play into the IoT platform. That's really important because you keep building the library, so the more of the devices you have, the easier for your devices to be plug and play into your network and enable your partners or other systems to do exactly the same thing. So that's why we create over 3,000 device models already. Again, right, we need to make it open. The device model, you need to follow some standard, for other developer to write their driver into the IoT platform. The second one is the protocols. For everyone to work on device drivers. We are talking about industrial level of devices. So they are talking about different things, right? For example, IEC 103, IEC 104, OPC, right? There's so many different industrial protocols you have. We got to store the most popular, important protocols, adapters into the platform. So when you're writing a device driver, you could just pick whatever already here, right? So for OPC driver, and then you create your own configuration for the driver, and then it will talk easily with your devices. That's why we created we already accumulated over 138 protocol adapters in the platform. That's exactly the asset. Keep building the assets, really important. The last one is we need to have some kind of configuration tooling for users or the configurators to plug in those devices. You could say, in my home, I can just scan my barcode, right, to connect one of the smart appliances to the network. For the turbines, also in our portal, in a configuration portal, you can specify where's the IP address of your edge component and what kind of turbine model you have, and then the device directly connect to the network and create value. So that's the most important thing for the connectivity part. So we need to have like device library for the asset. We need to have like really easy tooling for you to do configuration. After we get the device connected to the network, the next is how do you like be able to handle those data, right? So in AWS, we have like underlying, there's lots of like platform services. You could store the data. But on top of the data, we got to have like data lake, and we got to have data machine learning like on top of the data. So that's why in the middle of the heart for any enterprises, we need to have the data lake to get your data. Those data could range from real-time asset data, like for example, like your devices, your machineries. Those are the device measurements, your device master data. The second one is like the related data, the context, like the data context. For example, in the energy sector, we got to have weather data. We have like terrain data. Those are related to your devices. Otherwise, without this kind of context data, your device data actually wouldn't make much of value. The next is you got to integrate your ERP, CRM, your traditional IT systems data with the real-time, with the device data. I'll give you one example. For example, like if my device has a problem, right? I can detect a problem from the real-time data stream. What can you do? Actually, it could create an alert. The alert actually will trigger from SAP a ticket system, right? A work ticket system. I create a ticket for a human being to go there to check out the devices. So that's how you actually bridge like the data from the real devices and your workflows from the traditional IT systems. Like so we got to have like end-to-end tooling also. Like first, we need to like bridge the difference like from the IoT, the real-time data stream, with the batch like data models. For example, so lots of data actually coming from your databases, from MySQL and from your Oracle, from your other like Microsoft like SQL Server, right? All the data from other enterprises. We need to have a way to ingest data into the platform, like no matter it's real time or batch mode. And we also need to visualize those data easily to do business like exploration. So you can see the data cube. You could drill in the details. You could like do aggregation. You could do like visualization. Like all this actually related to tooling. We need to like have like really smooth tooling. Like from injection to data lake, to data mining, to machine learning, and the visualization. All this are actually on the top bar is all about tooling to make everything smooth. That's on the data part we learned like in the past. So I'll give you an example like how IoT, the real-time IoT and machine learning, the big data can help. Like that's a concrete use case. What this is about is like in the T&D, the transmission and distribution of the grid. So the cables is really important part. If you get a cable overheat, so it generate an outage of your building, of the district it manages. So that's why how to predict like your cable doesn't have problem. So we need to have like a measurement, a sensor, like put like besides the cable. Now you can measure what? And measure the current, and measure the temperature of your cable. All this information are flowing to our IoT through the edge on the left-hand side, right? So real-time data stream through the edge. The edge actually go into the message bus of our platform, and that will trigger the stream processing. The stream processing part actually it will leverage a lot of like prediction models already built from past. So the models actually we could see that like it's coming from the machine learning part, but let's assume that it's already here. Now the stream like the stream processing will trigger the models to predict whether the cable is overheat, or actually it will be like it's an outlier, or there's any problem. If there's a problem, it will trigger an alert into the human being like interface. So human being now, it will need to like click, say, I send someone to like service my cable, or it's a false alarm. So this information is again right back to the machine learning part to close a loop, right? So we have the real-time data stored in the historical database with the human being doing the labeling. So this kind of information actually flow into the training process to keep enhance our prediction model over time. So the more so we're running the system, the more, like with lots of real-time data, we accumulate lots of historical data, we accumulate lots of user actions of data. So we will make the entire model better and better over time. So that's a traditional way to do, really good way to combine IoT data streaming training, data streaming alert, prediction with the batch mode to do the machine learning. For security, so thanks for the AWS. We have done a lot of we have achieved infrastructure level security easily. For example, we don't need to worry about physical security. We don't need to worry about network protection in this case. So we could later talk about lots of the security model, how to do a shared security model between AWS and the application. I want to focus more on the application itself. So on the application, we are creating a platform for enterprise, right? Actually, the platform itself is an application on top of the AWS infrastructure. So what we think about that, we need to leverage VPC to do isolation about between clients. So we need to do how to do role-based authentication. We need to do single sign-on and we need to do authorization. How do you authorize other people to using your data? For example, you are getting application coming from different developers. So as a customer, I will pick one application to use my data. How do you authorize those data? So we got to have a really complex authorization model to allow applications to use a customer's data if the customer want the application to be able to read the data. The other one is data encryption. It's a really hot topic actually, right? So you don't want to impact your performance. If you store the data and then you retrieve data from the database, you don't want to create extra program model, right? So how do you do that? So we have partners, for example, Bayful. They create a library that allow you to do on the application side to do data encryption and decryption easily without changing your program model. So actually it intercepts the call into the database and then encrypt the data according to your configuration and then also decrypt the data to the application. So you don't have anything you need to worry to change your application programming model. So those are the data encryption can be on the application side and it also can be enabled by the platform. So we could enable automatic encryption for S3, for HBase, and other data storage. Again, right, so operation of the entire platform, actually the logging and auditing is really important also. This is how the customers trust you. You could do incident response and based on all the logging and auditing of your systems. This is how we leverage AWS different services. As you might know, we want to be able to take the fundamentals of AWS. That including the EC2, the auto scaling, and the VPC, and a bunch of services. This is how we leverage all those components already. Now we are thinking. So besides of that, so we are creating a platform on top of a platform. So what you can do for other benefits from AWS. AWS has a really good edge framework we call Greengrass also. So this actually it could be one of the edge types in our system. So we are talking about some of the edge component from a battery, for example, from smart appliances. They may not have the Greengrass available, but some of the devices can always run the Greengrass framework already, so that we could easily plug in a Greengrass enable devices into our network. The second one is for machine learning. We need to support different machine learning models. For example, no matter using R language or Python, right? Whatever. So we create an open platform for machine learning. But actually as an enterprise, you might want to leverage what AWS already created, the machine learning services from Amazon. So that's why our platform is open to integrate with third party, like any machine learning infrastructure into our platform. Now we're talking about why we partner with AWS. We started the journey back to 2013, 4 years ago. So because we are a global company, we have clients all over the place. So we are not going to build anything by ourselves to serve global clients. So that's the first #1 benefit we get from AWS is to be able to reach out to our global customers. So we have US, we have European, we have Asia customers. So we leverage different data centers of AWS to serve our customers for data privacy and for data protection, right? According to the law and regulation, we cannot get the data outside of the local countries. So that's the first one, we get global outreach. The second one is for performance, for scalability. All this for cost, we leverage AWS. And besides the technical part, actually the interesting part for AWS is that, we actually partner with AWS to share our partner network. So we have partners from technologies, from ISVs, and also AWS actually have lots of partner programs also. We learned from each other, we share those partners. We create we have innovation day and customer day to share our technologies all together with those partners. And last but not least, actually we go to market together with AWS. So AWS has lots of customers, ranging from utility and then to other enterprises. So our major customers are utility companies right now. So we share the contacts of our customers. So we could leverage, we actually from our part, we could sell our applications or the entire system easily, with the help from AWS. Now I want to tell you about a few of the customer successful stories for digital transformation with the enablement of IoT and the cloud. This is the client list of our current system, or the NOS. So including the major utility company or the renewable companies from US, Europe, and Asia. Let me get you one of the, going back to the original thought about digital transformation. Now you have many devices, hardware in your system. How do you manage those devices? The first one is that, example of CGN. CGN is a really leading company, manage lots of renewable assets in China and also in other countries, for example in India. So what they're doing? So they have lots of assets already. They have thousands, over 7,000 of wind turbines. They have 2 gigawatts of solar assets. That means that there's millions of inverters actually. So how do they? If you send people to do local management, it's not practical. So what they do is to connect their devices to the user IoT platform to connect all their devices. They're doing central management and control of their devices. They have central reporting and performance management of their assets. So from there, the digital transformation for this company actually can reduce over 60% of the cost to manage their assets. That's the first #1, to cut the cost. The second story is talking about besides the monitoring and control, what can you do with the data? So normally, right, you input the performance. You also need to cut the cost about to do preventive maintenance to prevent the loss in the future. So in the second scenario, it's another utility company in China. So they have they actually have more assets than the CGN we mentioned in the past. They also collected lots of data already. So if anything goes wrong for your asset, it causes a breakdown of the asset. It will cost a lot of money to stop production of the asset and do the maintenance. So what we do is, for example, for bearing in their wind turbines. So we create a lot of data. We're using physical model plus the machine learning model. We're able to predict a bearing will break down in 6 months ahead of it really happens. This 16 months actually will cost you just a few hours to do the maintenance in a local farm, right? So that is it costs a little bit money. Actually, save you like millions of dollars in the future. That's how we so. Actually, in the middle of this kind of case also, like based on the IoT like sense data, we need to put more sensors, like the CMS, like to the vibration of the problematic machines. You to get more data. That's why like that become a millisecond like a data collection. So we connect we could process lots of data to really find out like for the problematic like wind turbines, it's really the bearing has a problem or other parts have the problem. The number 3 case is like so besides our maintenance, we need to generate more value, right? We need to improve our power generation, like and our revenue. In this case, right? So in a grid, the more power you generated, the better. But actually, the grid doesn't want you to generate that much if you cannot predict like your generation like correctly. So and actually in some of the grid, they will give you a penalty also if you generate like not compliant with the regulation. So now like IoT platform enable like as we said like the data lake. First, like if you do a really like accurate prediction about power generation, right? Like you need to get like the really precise local weather like measurement. Each of the turbines actually have a map mast like associated with it. So we like globally we have like more than like 10,000 of the map mast weather station to collect those data real time. You get the real time data, your data streams, right? So but you also need to know about the device status. If the device has a problem, so actually it cannot generate that much energy. So you need to know about all the sensor information to do an accurate prediction also. Besides that, we need to get the data like coming from the context. We're talking about context, right? Like so for weather data, so we get the data from NASA. We get the data from other satellites also. This kind of data will enrich our context to create really good like prediction. So now you combine multiple data sources all together, and you need to like for prediction, we need to select like multiple features also. We could have like by default, we have like 20 or 30 columns of data like from different data sources. We need to experiment like those data to combine features and create like new features. Like actually in the real case, we create over 1,000 of machine learning like features from the feature engineering based on this kind of data. And you need to using model selection to predict, right? So we using physical model first. Physical model actually, we could predict some of the basic outcome from the physical models, and then we apply machine learning model also. For example, like you could using a gradient decision tree to do the prediction. You could try other models also. We try over 20 models and find out which one is the best to create very good performance or prediction. So you can see that from data-driven applications, if we increase the accuracy from 80% to 86%, actually we can save over millions per wind farm per year. For digital transformation, we are not just focused on the legacy enterprise. We need to enable for the innovation, the innovators also. Like for Sonnen is a German company that focus on storage for residents. So what they're doing is they need to manage their devices. Like they have over hundreds of thousands of devices globally. In the past, they have a problem to manage their devices with a good performance. They also need to enable the business model for machine-to-machine trading, for example, right? And to participate into new grid services. What we do is with them to enable them to have IoT platform to support this kind of innovator, to create a reliable system and to enable their new business models also. So now they could respond to the grid, right? If I want to sell energy or and reduce the load globally, or they can sell energy to each other. The last one, the scenario I want to share with you is that, so for new business model for enterprise, we need to create new income revenue stream. So for CLP China Lighting Power is a leading power company in Hong Kong. So what they do is they have reached reliability of over 99.9% of reliability already. But what they want to do is to create new business models, like with their customers. What we need to, we enable them to transform themselves from just a grid operator to a smart city operator. What it does is that first, we enable them to connect to their end users. Between the grid and the companies and the end users, normally from your perspective, it's just a bill, right? But now, enable smart home and smart building, they will be able to have the transparency into their customers' devices. We also enable smart building and also industrial park, transparency, visibility to the grid also. Besides that, so from here, from the grid operation, you have the transparency from the power generation to the consumption. You could have new business models. For example, you could give credit to anyone could help you to reduce a load when your capacity is over the limit. So that's what the new business model called demand response, or frequency response, available in the grid system with their customers. That will reduce the investment of their hardware and also improve the overall performance of their investment. Eventually, right, so how enterprise is create a new business model. Now they need to connect to their supply, right, the power supply, and also connect to their demand also. In the middle is lots of constraints you could have. Like for example, the capacity, the pricing, and the user feeling of the user experience. All these constraints will be put into the entire system and to create a dynamic computation matrix for you to optimize the entire network. With this kind of intelligence, so this is really real-time operational intelligence. You could balance the load between generation and the supply. You could improve your overall throughput. You could create new business models. And that's how CLP actually arises from just a pure a utility operator to you can manage other utilities also, for example street lights, EVs, night security, surveillance, right? All these have become part of the entire ecosystem of CLP. Again, right, so now we can see that we not working alone. So we are working with lots of partners all together for digital transformation. So we work with partners to create this platform and application to serve our customers. In a real case, we actually for AutoGrid is a leading utility security technology company for utility companies. So actually we provide benefits for AutoGrid, right, to get their, for example, spread out their market across the whole world. Because lots of companies already adopted our platform as underlying digital transformation. So all the applications are onto the platform. We will actually reach out to our customers easily. So that's how for CLP case, the AutoGrid will become the choice of the demand response application, for CLP. The second one is we provide technical support for our partners, and for example, training and free trials and usage of our platform. And actually, we are a huge company already, the enterprise. That's why we have a venture capital, from Envision. So we provide venture capital, we provide investment also for our partners. And from technical part, so we have our own, on top of AWS, we provide a whole set of tooling also, as a development center. So from here, you could connect to all the devices, create device models, create applications, and deploy your applications. And you could contribute the application to the application store to allow people to pick whatever in the store to serve their customers. So from again, thanks for everyone to listen through the talk. So what I want you to remember from this talk is digital transformation is a must-have for enterprises. And besides the traditional one, IoT will give you another opportunity for the next 10 years. And for IoT, so we need to focus on connectivity. We need to focus on big data. We need to focus on how to create value from the intelligence. We need to create synergy between data, and we also need to focus on security. But for all this, actually, you need a platform. You cannot do this alone. Basically, you got to pick a technical excellence to serve you better. So if you build everything from scratch, it takes a long time, just like Envision. We take a long time to build up this platform, but we want to open up this platform for our customer to use. That's why our goal is to make sure that we open a platform and we also make it available for our partners and our developers to work on the platform to better serve our customers. Okay, thanks. And then next, we are coming back to the Q&A section to talk about how do we do more transformation, based on the, for example, HPC and SAP and those applications we on top of the cloud. Thanks.
Thanks, Colin. Hello, everyone. Glad to see you join our session today. I will introduce 3 topics: security model on AWS, tips of expanding Citrix to AWS Beijing region, and SAP migration use case. Now, security and compliance is always a first priority to any customer, especially to enterprise, right? So that's why I will talk about the security firstly. As you can see, there are 2 storylines in this picture: security and compliance. AWS will help customers to build the security assessment, security strategy, and a security health check. And there's many AWS services to help you to keep you safe and compliance. For example, we have AWS Cloud Trail that will automatically record all the service change. For example, you can this will give you a report to let you know who creates an EC2 instance, who stop it, and who terminate it. In this case, Envision want the data transparency. So they want to know who creates the data, who changes the data, and who deletes the data. And the Envision also needs to check whether the security policy is suitable on AWS. If no, what's the difference? And they also want to get the compliance certification that they needed. So as you can see, AWS can help customers to run the compliance assessment and a compliance jumpstart. And we also have many AWS services to help you. For example, AWS Artifactor can let customers to download any compliance application that AWS got. And if you want to know the network traffic within the VPC, AWS VPC flow log can help you. And if you want to demonstrate the compliance, you may need to access the historical configurations of your resources. That AWS config will give you an overview of your resource. And the CAF means Cloud Adoption Framework. CAF will help customers to understand how the cloud adoption to integrate with your current process. And it will relate the stakeholders into 6 perspectives, which include the business, people, security, operation, governance, and platform. In short, enterprise customers can leverage AWS service to build a unified security and compliance model to keep you safe and compliance. Here's the roadmap of Envision's cloud journey. At 2013, they start to migrate some lab application or dev and testing environments such as the EOS to AWS. And at 2016, they start to migrate Citrix to AWS Beijing region. And during the 3 years, they also continuously migrate many internal enterprise applications. 5 months later, they start to migrate SAP to AWS. I will introduce the detail how Envision migrate SAP to AWS and how Envision expands Citrix to AWS Beijing region. And they have planned all in cloud in future. Envision is the first client to expand Citrix to AWS Beijing region. Why? Because they don't want to maintain any physical server. They don't want to worry about the security issues, the package updates, the tough operation tasks. They want the cost down. That's the reason. So I'm sure you can find many best practices that will teach you how to deploy Citrix on AWS. And you know, there's two most common scenarios. In this project, we choose the hybrid extension model. I'm not going to tell you how to deploy the details. What I'm going to show you is the lesson learned we've got in this project. The first tips is, if you need to manually specify the EC2 endpoint when you initialize the DDC using the PowerShell, not the console. The reason is the Citrix don't support the console in AWS Beijing region. The second tips is, please do not delete any default subnet or default VPC. In this project, we found a weird phenomenon. The EC2 instance can be automatically created by the Citrix, but they will be deleted a few seconds later. We double-checked all of our configurations many times, and everything is okay. And we also asked customer, do you delete the default VPC? They said no. Then we asked the Citrix for help. The only clue is the Citrix need to create a tiny EC2 instance within the default subnet within the initialized stage. So we came back and double check, and we asked the customer again, do you delete the default subnet? They said yes. So the root cause is someone deletes the default subnets and keeps the default VPC. So again, please do not delete any default VPC or default subnet at any time. But now, customers don't need to worry about this because AWS can support customers to rebuild the default VPC and the default subnet by themselves. Here's the architecture of Envision's SAP on AWS Beijing region. The customer in the data center, they met the performance issue. They have to make a decision either to rebuild SAP in the data center or rebuild it in AWS. After evaluations, they choose AWS. There are many reasons. Some of them are customers think AWS can provide a more powerful instance to improve the performance, and AWS is more stable compared with the data center, and more convenience to upgrade the instance to run the maintenance and operation task. After 3 months, customers successfully migrate SAP to AWS. The key for this project is not just a lift and shift, it's an SAP transforming from the Windows platform to SUSE platform, SQL Server to Oracle. The partner is Hande, one of the biggest SAP partners in China. And we consider the failure for every component. We use the AWS EC2 auto recovery feature to mitigate the single point risk. And we also use customer also periodically run the EC2 snapshot to back up the data and use a third party to back up the database log and store them to S3. And we also enable the S3 lifecycle to move the code data to Glacier. And we also use the DNS to fail over to different availability zones. And the key for this project is SAP migration to AWS is not a tough task. And you can find many usage information and how they migrate. Okay, here's a takeaway. Colin also introduced what's the Energy IOT platform and how they build on AWS and what's the benefit of it. In my section, I also introduced the tips if you are interested to AWS Beijing region and you want to migrate some core enterprise applications such as Citrix or SAP to AWS, you may be benefited from this session. And if you are interested to this content, we can discuss offline. Thanks.
Yeah, thanks again for everyone to come in to join us. Like this is the first one, so like it's hard to like everyone stick with us like from the beginning to the end. So I hope like digital transformation. I think for enterprise, it's not an easy job. I just want to say, like Envision has gone through like this for the past like 4 years. We're starting from like building our own platform and open up the platform. And we also like focus on moving our applications from the internal cloud to the public cloud. So we learn a lot of information. We make the platform available. So if anyone is interested in talking to us more, how do we partner together, either create applications or using our application plus the platform to serve our customers, we are here to like open for any questions later on after the talk. So thanks again for everyone. Have a good day and enjoy the rest of the day like with event. Thank you.